Hello, my name is Ben Mallory and welcome to today's Science Short. Today we'll be talking about our weather station and our Met Pole. We'll be talking about the data that we collect from those two locations, and we'll be talking about why we collect that data and how we use it. So looking at Glinda, as we've affectionately named it, we have a sensor here. It's a combination between an anemometer and a wind vane. Now the spinning propeller is the anemometer portion that helps us measure wind speed. The wind vane portion is which way the wind is coming. So it's going to point the way the wind direction is coming, and that's going to tell us the direction of the wind. Next, we have this device here. This is a radiative casing. It's protecting three different sensors that are going to be sensitive to weather conditions. The first of which is a thermometer. That thermometer measures temperature. The second, a barometer. That barometer measures pressure. And the third, a hygrometer. The hygrometer measures relative humidity. And finally, we have an ice sensor. The ice sensor helps us detect when there are icing conditions present. So on the ice sensor, there is a vibrating metal pole. The metal pole vibrates. When the icing conditions happen, the metal pole, there'll be ice that forms on the metal pole, and it will affect how fast the vibrations are occurring, and that will then send us an alert that there are icing conditions present. Those conditions might be a freezing rain, a freezing mist, or even a freezing fog. Now join me as we go and talk about the Met station. Here is our Met pole. When I say Met, I mean meteorological tower. Now our meteorological tower is a 30-meter wooden pole. Now our pole has 5 different measurement devices on it, 3 anemometers and 2 wind vanes. Of those 3 anemometers, 2 are cup anemometers. A cup anemometer measures the wind using 3 different cups, and as the wind blows through it, it's going to spin the cups, allowing us to measure wind speed. The sonic anemometer is going to use a Doppler shift to measure the wind passing through its sensory location. The sonic anemometer is actually positioned at the very top of the Met pole, while the 2 cup anemometers are positioned slightly below it on 2 different arms extending from the pole. And below those, we have 2 different arms extending from the pole that have our wind vanes. The wind vanes move and rotate as the wind pushes them and are going to point in the way that the wind is coming. So that's going to allow us to collect wind direction data. Now the next step is actually collecting and processing of that data, and for that, we will return to Glinda. In order to collect data from all of the sensors that we've discussed, we have to use what's called a data logger. Now our data logger is housed in a compartment that protects it from any of the weather around, but it has to be co-located with the actual sensors. That is because all the sensors are connected directly to the data logger via different cabling. That cabling actually transmits signals from the devices into our data logger. So the cabling travels down from the cables and back into the data logger, and all of these mess of wires, all the different colors, they all have a very specific purpose. They're all specifically put into the data logger where they are in order to generate the data. So the signals are brought into the data logger, they're converted into usable data, and then we can access that usable data via the data logger. We do that via software that we have that we can access online through a remote connection with said data logger. Now for the most important part, we'd like to discuss why we're actually collecting this data and how we use it. So each of the sensors has a unique purpose. The anemometers measure wind speed. We need to understand how the wind is performing on our site. We are a wind energy company. Our wind turbines run off of wind, and wind speed dictates how much energy a wind turbine is going to create. So it is important for us to understand how the wind is flowing across our site. Now, as we've discussed, there are more than one anemometer that we have on site. We have one on Glinda that's going to measure the surface level wind speeds. We have 3 on our Met pole. The ones on the Met pole are actually measuring wind speeds at around 30 meters in the air. 30 meters in the air is a little bit below the lowest point of the wind turbine blade as it spins. At that measurement, we are able to calibrate our LiDAR. Our LiDAR will be discussed in a separate training video. But we were able to calibrate our LiDAR using the anemometers at 30 meters on our Met pole, and that is the primary function of that. And it is similar with the wind direction measured from the wind vanes on the Met pole. Now, the temperature, pressure, and relative humidity data that we get from Glinda is all used as a to help us understand what the weather looks on any given day. We have meteorologists on staff that need to understand when the weather is severe, when we are experiencing weather that we might need to shut down turbines for. This type of data helps us do that. And finally, our icing sensor allows us to measure, like I mentioned before, when there are icing conditions present on the site. It is important for us to know when that is occurring because we do not run our turbines when there's ice that forms on the blades. And that's going to cover the instrumentation that we have on site. Thank you again for attending today's Science Short, and remember, challenge everything.